All right, you guys, let's talk about the remaining information that will be on exam 2, the week of fall break. So we're going to start with chapter 6.1, confidence intervals for the mean. Okay, we're going to find a point estimate and something called a margin of error. And then we're going to construct and interpret confidence intervals for the population mean. And then at the very end of the lecture, determine the minimum sample size required when estimating mu. All right, so what the heck is a point estimate for the population mean? All right, a point estimate is a single value estimate for a population parameter. The most unbiased point estimate of the population mean mu is going to be our sample mean x bar. Okay, this is just fancy math talk for saying we're going to use the sample mean to build a confidence of how do we want to say this? To build a fence of confidence around where we think the population mean might be. Okay, so here's some raw data. A social networking website allows its users to add friends, send messages, and update their personal profiles. The following represents a random sample of the number of friends for 40 users for the website. Okay, find a point estimate of the population mean mu. Well, if you're asked to find a point estimate of the population mean, all you need to do is find the average of that sample. Okay, so how do we find the average? Well, I've already put the data in Excel over here. Let me bring this a little bit closer. Okay, so you can see I already have all the data in Excel. How do I find an average? Well, I can highlight. Well, I'll just go show you the long way here. Let's do average equals average. What do we want the average of? We want the average of all of our data. All right, so in other words, Excel adds it all up and divides by the number in the sample. And you can see that we get 130.8. All right, so our point estimate for the mean number of friends for all users of the website is 130.8. Okay, so what is an interval estimate? An interval, or a range of values, is going to be used to estimate our population parameter based on how confident we want to be. Okay, so the more confident we are, the wider that interval needs to be. The less confident we are, the more narrow we can make it. All right, so what is level of confidence? All right, level of confidence is the probability that the interval estimate contains the population parameter. All right, so we will typically use this little c to denote our level of confidence. And little c is the area under the standard normal curve between what's called critical values. Okay, so you guys have been finding, given the area in between two z-scores, you know how to get those critical z-scores. All right, we're going to use norm Sn when we need to get critical values. Okay. All right, so let's think about this. If the level of confidence is 90%, all right, this means that we are 90% confident that the interval contains the population mean. All right, how would we go about getting the critical z? Okay, so critical z-score, all right, is going to use, and I don't want equals yet, is going to use norm Sn of what? All right, it's going to be 1/2 of 1 minus the confidence. Okay, so here our confidence is 90%. All right, so I want 1/2 times 1 minus that confidence, and I'm getting 0.05, and I will use that as the area to the left of the negative z, so norm Sn 0.05, and you can see we get our critical z of negative 6.45 and 1.645. Okay? All right, so what is sampling error then? Sampling error is the difference between the point estimate and the actual population parameter value. Okay, so for example, I could get the average age at one of the face-to-face Excel sessions, and maybe that average age comes to, I don't know, maybe 18.6 years old. Whereas if I'm using this as a point estimate for the average age of USC Upstate students, then the sampling error would be the difference between that 18.6 and the actual population average age for USC Upstate students. Okay. For mu, the sampling error, again, is the difference between the sample average x bar and the population mean of mu. Typically, mu is unknown. Just think about it. In what situation can we really get the average for everyone in the population that we're wanting? Census data tries, but still there's no way that census data is really on every single person living in the United States. All right, and the sample average, of course, is going to vary from sample to sample. Okay, so let's talk about the margin of error. The greatest possible distance between the point estimate, x bar, or the sample average, and the value of the parameter it is estimating, typically mu, for a given level of confidence, C. All right, so in other words, we're going to think of this as the width of our fence. Okay, and it's denoted by capital E. So when you see a capital E, that's the error or margin of error. And this formula that I just brought up, where we have critical Z times the standard deviation of our sample, all right, and you guys know now that that is just the population standard deviation divided by the square root of n, all right? So this error, all right, is something that we're going to add and subtract from our point estimate to get the width of our fence, okay? Now, notice what I'm saying here. When n is greater than or equal to 30, this is something that's going to be very important. We're always going to have to make sure our sample size is greater than or equal to 30, because when it's not, there's something else we're going to need to do. Just so you know, this margin of error in other textbooks can be called the maximum error of estimate or the error tolerance. Typically in applied math settings, you'll hear it referred to as error tolerance, but you will always hear me refer to it as margin of error, and certainly on your exam it will be denoted as margin of error, or capital E. Okay, so let's find the margin of error for our Facebook data. So we use the social networking site again. We want and a 95% confidence level to find the margin of error for the mean number of friends for all users of the website. Assume the sample standard deviation is about 53. All right, I'm going to go through it the long way with the formula, and then I'm going to show you the way you'll actually be doing it in the homework. Okay, so let's go through finding critical Z. Okay, so we need to get 1 minus the confidence level divided by 2. All right, I do this and I get 0.025. All right, this is what I need to get my critical Z-score. So critical Z-score is going to be norm Sn of the probability to the left of that negative Z, which is 0.025, and I get negative 1.959. Okay, I can round that up to 1.96 or negative 1.96. Okay, so 95% of the area under the standard normal curve falls within 1.96 standard deviations of the mean. Okay, so that blue shaded region is 95%. Okay. All right, let's go through the formula And again, I'm going to show you a much easier way to get this. Okay. So we don't know sigma, but since we have more than 30 in our sample, we can use the sample standard deviation in the place of sigma. All right, so we have our critical z of 1.96 times our standard deviation of 53 divided by the square root of our sample size. Okay, when I plug all this in, I'm going to get 16.4. Does it matter that I'm using the positive z-score and not the negative critical z? Absolutely not. If we used the negative here, then clearly that just makes our error negative 16.4. But remember, this margin of error is something that we're going to have to add to our sample average and subtract from our sample average. So its sign doesn't really matter. All right, again, I'm going to have to add it and subtract it. Okay, so here, going through the formula, recall on the previous slide, we used norm SN of 0.025 to get the 1.96. Okay, so here I've gotten my 1.96. In the problem, I'm given the sample standard deviation of 53, and I'm given my sample size, or I know my sample size of 40 users. And so I plug all this into my formula, and I get an error of 16.4. Okay? So we are 95% confident that the margin of error for the population mean is about 6.4 friends. All right, can we get this an easier way? Absolutely. So how do we calculate the margin of error? All right, so we have equals, and I'm going to say I'm going to start typing confidence, and I see confidence norm. That's the one I want. All right, my alpha is 1 minus my confidence. Okay, my confidence is 95%, so my alpha is 0.05, and I'll repeat all this. Alpha is 0.05, my standard deviation is 53, and my sample size is 40. And you can see I get a margin of error of 16.4245, blah, blah, blah. Okay, so again, let me stress what we're going to need for this formula. We need our alpha. Okay, alpha is defined as 1 minus the confidence, which here is going to be 1 minus 0.95, which is just 0.05. All right, we're going to need our standard deviation, which equals 53, and we're going to need our sample size, which equals 40. Okay, and that is what we plug in, as you can see here, to our formula to get the margin of error. This is going to be confidence.norm, and this is all in the notes in a little bit, 1 minus the confidence. Let's call this sample standard deviation and our sample size. Okay, that's all there is to it. Okay, so now when we want to actually construct the confidence interval for the population mean, again, what I just said a minute ago is that we're going to have to subtract and add this error to our sample average. Okay, so the probability that the confidence interval contains mu is C. Okay, so we build this fence, all right, using the sample average and this margin of error. And what we're saying is that, you know, that the probability that the confidence interval contains this population mean that we don't know what it is has to do with how confident we are. Okay? So, when you are constructing confidence intervals, what are your steps? What are you going to do? Okay, and I'm going to break it down not only with the formula, but what you're going to do in Excel. All right, given some data, okay? we need one of two conditions. Either our sample size has to be greater than or equal to 30, or sigma has to be known, meaning our population standard deviation has to be known. Okay, so the first thing you're going to do is you're going to check that you have one of these two conditions. Okay, so again, step one, make sure sample size is greater than or equal to 30, or the problem says the population standard deviation is blank. Once you say yes to one of those, then we can start working in Excel. Step one, we're going to find the sample statistics in an X bar. All right, so obviously within we can just get a count of how many data points we have. And with our sample average, we know that in Excel we just type equals average and grab all of our data. Okay, if the standard deviation is known, it's in the problem, then great. If we're given raw data, we're going to need to calculate the sample standard deviation. Okay, even though this is the formula, we know how to do this using our formula in Excel of equals stdev.s, and we'll grab all of our data. And then we're going to find the margin of error given our confidence level C. All right, so how do we do this? This is going to be where we go in Excel and we type equals confidence.norm. All right, we're going to type in here 1 minus C, using decimals, of course. Our standard deviation, now this could be S if we had to calculate it. All right, given some raw data. So it's either going to be the population standard deviation or the sample standard deviation. And then in our sample size. Once we have this error amount, all right, then we're going to add it and subtract it to our sample average, all right, to get how wide our confidence interval is. Okay, so let's actually go through it. Let's construct a 95% confidence interval for the mean number of friends for all users of the website. Okay, so recall that our sample average is 130.8, and our error we found to be 16.4 friends. All right, so I'm going to subtract 16.4 from 130.8, and I get 114.4. And I'm also going to add it to the sample average to get 147.2. And so I get this confidence interval, or this fence around where I think the population mean is going to be. So I have 114.4, all right, to 147.2 friends. Okay, with 95% confidence, you can say that the population mean number of friends is between 114.4 and 147.2. Right? That's our interpretation. Bank on the fact that I will ask you to interpret this on the exam. Okay? So again, what is the ho-hum of all this? Because you guys are going to be able to get your numbers very quickly. You will calculate your 114.4 and your 147.2 very quickly. But what the heck does it mean? Why are we even doing this? Okay? We started with a 95% confidence interval. Therefore, with 95% confidence, we can say that the population mean number of friends is between 114.4 and 147.2. All right, let's go through another example. A college admissions director wishes to estimate the mean age of all students currently enrolled in a random sample. In a random sample of 20 students, the mean age is found to be 22.9. Okay, so that is our X bar. That is our sample average. From past studies, the standard deviation is known to be 1.5 years, and the population is normally distributed. Construct a 90% confidence interval of the population mean age. Okay, so before we start, do we have a sample size bigger than 30? No. Do we have a known population standard deviation? Yes. That is 1.5 years. Okay, so actually I'm going to go back to this site. All right, so now what do we have? Let's just label everything. We have, all right, n equals 20. All right, x bar equals 22.9. We have sigma equals, so our population standard deviation is 1.5, all right, and our confidence equals 0.9. All right, so let's construct a 90% confidence interval. Well, our error is going to be, confidence norm, all right, of 1 minus 0.9. Standard deviation is 1.5, and our sample size is 20. Okay, so we're getting an error of 0.55. All right, our, let's call it left endpoint, right, is going to be x bar minus the error. All right, so I'm going to do, let's go make this a little bit wider. So this is going to be equals 22.9 minus this error, and our right endpoint is going to be x bar plus the error. All right, so this equals 22.9 plus the error, okay? And so you can see that we are getting a confidence interval of 22.3 to 23.5, all right? All right, so what's it mean? What's the interpretation? With 90% confidence, you can say that the mean age of all students is between 22.3 and 23.5 years. Do we know exactly what it is? No. But with 90% confidence, we can say it's between 22.3 and 23.5. Okay. So again, let's go through interpreting the results one more time. Mu is a fixed number. The population mean is fixed. It is either in the confidence interval or not. All right, so it's incorrect to say there is a 90% probability that the actual mean is in the interval. That is incorrect, okay? The correct interpretation is that if a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of these intervals will contain the population mean. Okay, so again, if we keep sampling large samples and a confidence interval is created for each of those samples, then approximately 90% of the intervals will contain the population mean. Okay, so here's kind of a visual interpretation for you guys. The horizontal segments represent 90% confidence intervals for different samples of the same size. Okay, so remember, we don't really know this pink line. Okay, we don't know this pink dotted line, but I'm giving it to you for this visual. That's our population mean. And each of these is a 90% confidence interval for some sample size n. All right, so each of these black lines is a confidence interval of 90%. All right, what this is saying is that in the long run, 9 of every 10 such intervals will contain mu. Okay. All right, so the last thing we want to talk about is solving for sample size. Sometimes we want to figure out how large do we need to make our sample given some confidence in error. So given a confidence level and a margin of error, the minimum sample size n needed to estimate the population mean mu is given by this formula, where the sample size is equal to the critical z times the standard deviation, all divided by the error, and then squared. Okay, this is a formula you will need to know for your exam. All right, of course, I let you guys have a note card. So in other words, you're going to want this on your note card. If the standard deviation is unknown, you can estimate it using the sample standard deviation, provided you have a sample with at least 30 members. So again, we either need a known population standard deviation or a sample size of at least 30. All right, you want to estimate the mean number of friends for all users of the website. How many users must be included in the sample if you want to be 95% confident that the sample mean is within 7 friends of the population mean? Assume the sample standard deviation is about 53. Okay, well, we need our critical Z. Critical Z, again, is found by using norm SNV of 1 minus, so let me grab my pen here. How did I get this 0.025? How are you going to calculate it? It's 1 minus the confidence level divided by 2, as we can see from the graph. So 0.95, 1 minus 0.95 is 0.05. 0.05 divided by 2 is 0.025. When we use norm SN of 0.025, remember Excel is going to return this as negative 1.96. It doesn't matter whether we're using the negative or the positive, might as well use the positive. Okay, so our critical Z is 1.96, our sigma, our standard deviation, is 53, and our error is 7. We plug this into our formula, okay, and get approximately 220.23. All right. Obviously, we're dealing with people here, right? We're dealing with friends on Facebook. We can't have 0.23 of a friend. So what are we going to do? We're going to round up to obtain a whole number. All right. So how large does our sample need to be? All right. We need to include at least 221 users in our sample.